Now we are going to be taking some rules for the diagram and some basic thing before we actually start off with the diagrams. Okay, quickly tell me this. If this is the lens given to you, or yes, Anushka, answer this. If the radius of curvature, both the radius of curvature are equal, R, that is, if I'm referring R1 and R2, radius of curvature, if they are equal, then what is this lens called as? Yes. What is this lens called as?
I'm not sure.
Okay, Michelle, Adit, what should we call this lens if R1 and R2 are equal?
Is it equiconvex lens?
Yes, it's going to be called as equiconvex lens. Okay, same thing if was an concave lens where again R1 and R2 are equal. Radius of curvature decides a lot of things, right? It also tells you about the focus, tells you about the type of lens. So if R1, R2 are equal for the second one also, you will call the second type of lens as equiconcave lens. You all can quickly draw this and just write the condition there. We have already taken this in the previous lecture, but still if you're confused, you can write the condition and draw that. And of course with the name. Done writing everyone?
Yes, ma'am.
Okay. Now some conditions we will quickly see before proceeding. So if I have been given, let's say, just an imaginary part though, okay, so these two circles, uh, so this region that you can see is forming a lens, that means they belonging to two different spherical um, structures, and the intersection is going to form an convex lens, correct? So if you try to draw a straight line, you want the technical things over here. So if I draw a straight line that will connect the center of curvatures and the optical center. Now for convex lens, you will all write down. For convex lens, whenever you're going to take C1 and C2, where should you place the C1 and which is your C2? So the right side is going to be considered as the C1, that is center of curvature, first one. And to the left side, you're going to consider C2. Okay, so you can write in short, like when you read your textbooks and all, it's like in a lengthy way they have drawn and explained and all that lines are there. So shortly you can do a summary note of everything that is just apt for you all to consider for the diagrams, because they're not going to give you big definitions. They're not going to ask you all big things over there that is to be written in paragraphs. So only the important key points we are going to write down. So whenever it's convex lens, C1 will be on the right side of the lens and C2 will be on the left side of the lens. Okay, that means even if you try to just get rid of the circles and you only focus on the lens you obtain from those two circles, okay, and that means C1 will be here and C2 will be here. So write that down. Finish with the first condition, everyone. Okay. The same thing will be for concave lens. So if you have a concave lens, we know it's a part of a circle. Two circles are there. Okay. And we have a straight line, that's the principal axis. Again, you're going to have two centers and there will be an optical center. So in case of a concave lens, you will write which one you will take as C1 and C2. So C1 will fall on the left side and C2 will fall on the right side. Okay, so roughly draw this and write the 2 points. Okay, now remember when you're going to take the focus for the wherever you have written C2, okay, just remember they are just going to be opposite. The focus for that on the right side will be consider F1. So it's not like on the right side it is F1, C1 and the left side it is the C and the F will have the same numbering. Why they have different numbering depends on which focus you are going to refer. So there will be two focal points, we'll discuss that. But for now you can just write on the right side where you have written concave lens, you can also add up the focal point. Right side will be F1 and left side will be considered as the F2. Now F1 and F2, they are the two focal points. So F2 will be on the left side and F1 will be on the right side. This becomes much easy for you all to understand where will be the image formed. And same thing, just do for concave. I just missed out that. So when you have written convex lens, that please, if you have considered C1 on the right side, write F2 also on the right side for convex lens, okay? And F1 will be on the left side. Yes, finish writing everyone. Like if you all are referring Selena book, in that there is a concept of optical center given to you. So optical center will be both for the convex as well as the concave lens. Okay. Now what is an optical center? You see that's the centermost point we consider. But it's actually a point on the principal axis. So if I may ever ask you, optical center, does it lie on the principal axis? Yes, it lies on the principal axis. And if you try to make, see, we have done the refraction concept. Technically, if a ray is going to hit on such a way that it points towards the principal axis, I mean, sorry, towards the optical center. So there is always some refraction that it will go through. So we will try to show it. Suppose it hits here, okay? There will be slight bending it will go through, and we'll use different colors to understand bending. You will draw normal there, and then it is going to bend towards the normal. And let's see after uh, such bending, so it is always directed to the center. We will make a point that should have actually gone through the center, but because there is a refraction, slightly gets adjusted to the side which is little away from it. Okay, so what we will do, we will try to shift it a bit close, very slightly close, and it will go very straight, and then it will go little away from the normal. So we know, if you want like multiple lines shown, very slight deviation we will try to show, and it should have actually gone through the optical center. Okay, if it would have gone through the optical center, this is how the path should have been. But there is a very slight shift that you can see. What is the shift called as? Yes, Rachel. What is the shift called as under refraction?
Deviation.
No.
Yeah.
What is the shift called as? Deviated is like how far it is getting extended from its bend. But the shift that we have, a parallel shift, what is that called as?
Moving away from the incident and the
That's called
left.
as lateral shift. That term is called as lateral shift. But we will be considering that lateral shift very much evident when the lenses are taken too thick. But all in our chapter that we're going to take, we consider the lens is so thin that we can technically ignore that lateral shift. Okay. The point is there is refraction, there is a lateral shift, but for all the diagrams we are considering just to understand the concept of refraction for lenses, we ignore that lateral shift. And what we say is that if you have been given any lens, I'm just taking the convex lens here. So if there is any ray of light that technically passes through the optical center, okay, we ignore it, but there is a lateral shift that actually happens. But we just say that if it is passing through the optical center, it will go undeviated because we're just considering that shift is very, very small and very negligible. So what is optical center? It's a point on the principal axis. Definitions, as I said, I'm not taking that in the live class. We'll just understand concept. For definitions, the notes have been given, which you all can refer. So what is optical center? It's that point which will lie on the principal axis, and it is such a point that any time when light falls onto that, that means the path of light is such that it will pass through the optical center. So it will come out of the lens undeviated. That is the condition for optical center. So optical center is not properly the just for simplification we say it's the center of the lens, but that is not the actual definition. It's a point that you take it on the principal axis and a point consider through which if light goes it will pass undeviated. So such a point will be considered as optical center, and same goes for the concave lens also. It's not like only convex lens we're doing. So even for the concave lens, if we try to draw a line and there is some ray passing through a point going undeviated, and that point will be considered as the optical center. So two things is about the optical center. This will be useful when we do diagrams. So rays, the incident rays pass undeviated. You all can write this point. And secondly, we know that it lies on the principal axis. Okay, so write down these two conditions. Finish writing, then tell me. Done writing, everyone? Okay. Now is a term that confuses a lot of us, and that point is about the focal point. Okay, so the confusion is all about that there are two focal points. Which one should you consider while doing the diagram? Because you have diagram for the convex, or you get different images there, and for concave you have altogether different set of images. So while considering the focal point, which should be the one that you should take up? Should you take the left side one or the right side one? I've already given you the shorter key points that you can remember. But why one focal point for convex is different and for the convex is different? So first point, you should know what is a focal point, and there are two types of it. So we'll focus on this point. So there is a first focal point and there will be a second focal point. Okay, so concentrate here. This is very, very important because this is the most confusing part while we consider the diagrams and also the definition. Okay, now what is the shorter way to understand the focal points that we are considering for concave and convex? So first of all, we are speaking for first focal point. So for convex and concave, how we will understand convex, and you can all take the definitions from the PDF, but you all can write down this in the same manner I am giving so that it's easy to understand when you refer for revision. So we are considering the first one here, which is the first focal point. Okay. So for convex lens, how should you consider the first focal point? These are the these are the points that you're going to consider from where the light are going to come out. F1 I'm writing because focal point 1 we are considering. So for convex, light will come out from these point. And after it hits the lens, so here you have your convex lens. After it passes through the convex lens, there will be a refraction. And after refraction, after getting refracted, these lines will all start going straight. How were they? They came from this point, all coming out. In what way? They're all getting out in different with different angles. But after refraction, you will notice that all these have become parallel to each other. Okay, So for convex, when you consider the first focal, the rays of light should come from that point, from the point, and then it will be parallel to the principal axis later. And for concave lens, I'll just shift it here. This is your concave lens, and let's say this is your principal axis. Now, which one should you take as the first focal point? So it is that point that will come, that means the incident ray is such that it's trying to meet the focal point. From somewhere it is coming, and of course the rays will always come from the left side. Here also the rays were coming from the left side, and in concave lens also rays are coming from the left side. When rays are coming from left side and they try to meet at a point, so the point that they're going to meet, such that they think, they're trying to come to that point, but technically they're not going to meet there. In fact, they will hit onto the concave lens, and go parallel. So the concept is, after refraction, rays should become parallel. Now, how they are becoming parallel? In case of convex, they are the rays coming from the focal point on the left side, and for concave lens they're not coming from the focal point, they're coming from somewhere and they want to meet the focal point, but after refraction you see they're not actually meeting the focal point, rather they have become parallel. So this point to which they were trying to come will be considered as the first focal point. So you can clearly see here that the first focal for the convex is on the left side, and the first focal for the concave, it's on the right side. Okay, and that is what I had given to you before we started this lecture. The very first beginning I told you convex will have the first focal on the left side, and concave will have the first focal on the right side. So never consider, if you're considering F1, C1 should be on the same side, and if you're considering F2, C2 should be on the same side. No, that's not the case. The first focal by definition will be the focal point such that the rays after refraction should become parallel to the principal axis. So here the condition is, I'm writing it down, on what basis did you decide the first focal point? So rays after refraction should be parallel to the principal axis. To the principal, I'm just writing PA, just write the full form there, principal axis. So in case of convex, if you want after refraction it should be parallel, then that means the ray are coming from the focal point. And for concave, if you want the rays to be parallel, that means they're coming inclined from some point such that they appears that they are going to meet at focal, the right side focus, but they're not going to technically meet. They will not meet because the moment it hits onto the lens, they will start traveling parallel. Okay, any doubt in this, you can ask me right away. We have just done the first focal point right now. And be very careful, convex will have F1 on the left side and concave will have F1 on the right side. Done writing and done with the diagram? So tell me, then we can move to the second focus point. Done writing? Anyone is still writing any point? Yes, Adit, Anushka, Nidhi, Resham, Michelle, Ansh. Done writing? Nidhi, finish writing? Okay, now we discuss about the second focal point. Okay. Now, in both the cases, whenever you have to decide the second focal point, you will be considering that the rays are supposed to be parallel to your principal axis. Suppose I'm taking the convex lens, okay? And we have the principal axis like this. So the rays are going to be parallel. Now in both the case, for second focal point, we will take rays parallel to the principal axis. Use a like this, and you will take rays this way. Okay. Many rays you can take. They all come here almost to the center point. They all get diverted. We will also see diverging lens and the converging name. And they will all come diverge and they will meet at a common point. They will all be meeting. The bottom one will all go up and all the top one will go to the bottom such that they will meet at this common point. And the point they meet will be considered as your second focal point. So for convex lens, the second focal point will lie on the right side. How you decide that? Rays have to be parallel to the incident rays, okay? The yellow rays which is coming from the left side, they're parallel to the principal axis, that's your white line. Such that when they hit onto the lens, they will get diverted, that is, they will get refracted, and they will come to a common point. And that common point will be considered as your second focal point for convex lens. So the condition for both will be parallel lines. Parallel lines means incident ray has to be right like this. Incident rays parallel to the, not necessary the lines are parallel to each other. These lines have to be parallel to the incident, sorry, they have to be parallel to the principal axis. So incident rays parallel to PA. PA I'm just writing short as I said, it's principal axis. After refraction, after refraction will converge, you can write, or pass through the refraction, passes through the point called as second focal point. Done writing, everyone? Now we discuss how you decide the second focal point for the convex lens, concave lens. So we have principal axis. Again, you're going to do the same thing. You will all take the incident ray parallel to the principal axis. And just taking two, you can take many of them. So as the rays are going to almost reach the center point, these are diverging. So concave has the ability to diverge the rays. So what it will do, technically in reality, they are getting away. So this will go away like this. But if you would have tried to trace them, okay, which line are you going to trace back? The diverted lines. Or let me use a different color to make it more clear. So if I'm using a pink line to show that it got diverted, they go away. So whenever you see diverging line, they're actually never going to meet because they're going away from each other. So which peak they could have actually met, that ray you're going to trace back. So if you trace back that pink line from both the end, where are they actually meeting, on the right side or the left side? So if you try to make them meet on the right side, they will never meet. But if you try to trace back and make them meet on the left side, you can see they are meeting here. And the point they are meeting, they are actually not meeting. We are trying to make it meet because they're diverging, and diverging lines never meet. So we try to make it as it's as if it's appearing to meet here, and that point where they will meet will be considered as the second focal point for concave lens. So that is the reason for concave lens, the f2 is on the left side. Yes. Anyone has any doubt regarding the first and the second focal point for both concave and convex lens? Yes? If you have any doubt, you can ask me right away. Okay. So few quick conditions, and these conditions are important because for case study or MCQ, they give you all this tricky question. Now, if I am taking a lens, it can be any lens, okay? This is applicable for both lens. Now, the medium on the left side, suppose it is air, and let's say I've just attached it to a part where it is water. Okay, and medium over here is water. Lens is between two different mediums. So in such cases, my question is, will both the focal point, that is the first and the second, will they be same or will they be different? Yes, I want your opinions. So Anushka, what do you think? If a lens is placed between two different mediums on the left and the right side, it can be any lens, okay, I can replace it with a concave lens also. So will the first and the second focal point be same or will it be different?
It will be different.
Okay. Adit, what do you think?
Same.
Okay. Ansh, what do you think?
Same.
Okay. Nidhi, what do you think? Ratio. Michelle.
Different.
Okay. Ratio, what is your answer?
Different.
Okay. Nidhi. So maximum of you saying it is different, some are saying same. So the answer is they're going to be different. Focal length. Length, I'm saying. Length means from the center, optical center. Let's say this is your F, for example, I'm just taking that as an example. So this is F1 and this is F2, correct? That's how it is for the convex lens. So the length, this is the focal length, and that is the first focal length, and this is your second focal length. So it need not be same, it will not be same in fact when you have two different mediums on the left and the right side. But yes, if you have the same medium, let's say I have air on the right and the left side, then of course the focal length will be same. If you change the mediums on left and right side, they are not the same mediums. Then the focal length. Now, which focal length I'm saying? Both the length. That is the first and the second. They are going to be different. So write down this condition. If the medium, if the medium on both sides of lens, whichever lens, okay, it can be concave or convex. It's general statement for both. Is same, its first and second, its first and second focal length will be equal, or you can say will be same. So the because it will directly impact the refractive index, from which medium it is entering, from which medium it is going to go after refraction. Those medium play very important role in refractive index. And refractive index changes, it changes the focal length. That is some question that we have taken in the first lecture of this chapter. If refractive index changes, it directly impacts the focal length. Okay, done writing, everyone? Anyone is still writing any point? Okay, now suppose I take lens, convex lens, you can take concave lens also, and I have this principal axis. Now the rays, the incident rays I'm picking up, incident ray, they're all parallel to each other. Okay, this is, does that mean they're parallel to the principal axis? No, you can clearly see, but yes, they're parallel to each other. These white lines are parallel with each other, but they're not parallel to the principal axis. So my question is, will they all meet at the focus? That is, will they all meet? Will they all get, um, they're all, this is called obliquely incident. You get used to these words, obliquely incident. That is, they are just coming with some different angle. They're not parallel to the principal axis. They're slant, or they're coming maybe from the top or from the bottom, it's okay, but they're not parallel to the principal axis. So you're going to say oblique, and if those lines are parallel to each other, you can also call them as oblique parallel beams. Oblique parallel beams. Okay. Yes, Adit. What is your answer? Will they all meet at focus? Let's say this is focus 2. Will they all meet at focus?
No.
Okay. What is your answer, Anushka?
Ma'am, they won't.
Okay, Ansh?
No.
Okay. Rachel?
No, ma'am.
No. Nidhi?
No.
Michelle? They're all parallel to each other. Will they meet at focus? Second focus.
No.
Yes, so they are not going to meet because they're parallel to each other. So meeting at the focus is only condition if the lines are parallel to the principal axis. Then they will meet at the focus. But if they are not parallel to the principal axis, they might be parallel to each other. So that means they will all try to bend, and they might, meet And if they're parallel coming on the top, they will try to meet at a point which will lie on the second focus, but not exactly at the focus. Focus means they're not going to meet on that principal axis where we have pointed as F2. But yes, they will all meet at a point, a common point, which if you try to draw a straight line, okay, if you try to draw a straight line, that line must be going through the F2, but not exactly on F2 they will meet. They will all meet here. And if you try to draw a straight line that is perpendicular to your principal axis, then that line is actually passing through F2. Okay. So the condition is that it's somewhere going to be on that plane of F2. So this portion anywhere here on the top or anywhere, but if you try to trace a straight line and that line is crossing the F2, you can say it's actually lying on the focal plane. So if any of the rays are parallel to each other but not to the principal axis, after getting refracted, they will definitely meet somewhere on the plane of the second focal point. Okay, but not exactly on the focal point, but anywhere over here, maybe up or maybe down, but somewhere on the straight line. Okay, now the point is about why convex lens has been given a term converging and why concave has the term diverging. So you can quickly write this down. Convex lens is also called as converging lens. To converge is try to, make it meet somewhere from the light is all, instead of spreading out, they will all come close and try to meet at a point. So convex lens is also called as converging lens. Okay, and concave lens is also called as diverging lens. So they are technically going to converge light. So if you are confused about converging term, understand rays are all going to come to a point. This is called converging. And diverging means from a point or from many point, it will go outwards, all spreading out in different direction. This is all going to come close to a point. With the arrow mark, it is important to understand these are incoming rays meeting at a point, and this is outgoing rays coming out from a common point. So if you want, you can draw that small little picture to understand converging and diverging. Yes, done writing, everyone? Okay. Now, just we have to understand whenever the ray diagrams we will be doing. So if we take concave lens or convex lens, okay, at there will be two refracting surface. We know one is this left side, one is right side for each of them. So whenever you are trying to show any incident ray, there is no need to draw a normal and then bending away, again a normal and bending, towards or away. We're not going to show all these extra diagram. That is only totally applicable, and it will be unless it is mentioned in the question, but there is never a question they ask you for concave lens and for the convex lens. They ask you all that proper normal and bending and angles only when they give you prism based questions and glass slab question, which was from your previous chapter. There you have to properly show ray is entering and then you draw normal, and then you have to see whether it is bending away or towards a normal, and then you show the bending, then again you will draw normal. Okay, and then you will have to show away. So whatever is this, these kind of diagrams will be only restricted to the prism and glass slab. Apart from that, they will not give you and they will not ask you to draw all these details when you're taking concave convex lens. Now, one quick question I would like to ask everyone. Suppose I think I already asked you this part, but there was a second part of a question. I may take any kind of lens, it is concave lens I'm taking. Right now, I have covered the bottom part, that means the bottom portion is not there, or let's say I have covered it with a black cloth. Okay, so the only top portion of that lens is available for refraction. So my first question is, will the focal length change if I cover the half part of the lens? Will it change? Yes or no? Yes. Ansh, what do you think? Focal length, will it change if I cover half part? Like I just have the top portion of the lens right now. Will it affect the
No.
focal length? Okay.
No. No.
Okay. Michelle, what do you think?
No.
No. Okay. Maybe
No, ma'am.
focal length is not going to change. You take any portion of lens, it's still a lens. It will still show refraction. It belongs to a particular medium on the left and right side, right? The mediums, if you change anything on the left side, anything on the right side. Now, of course, that medium will always be with respect to glass because your lens is made up of glass. But what is the surrounding medium, whether it is air, whether it is water? Okay, if you change the medium, then definitely the focal length will change. Default, we take air, but they can give you questions for water and they give you questions just based on this that whether the focal length will change or not. And we do have a numerical based on this when we're going to take for water. Okay, and we're going to see that there will be, or they just ask you that theoretically that focal length, is it going to change if I put it into the water medium? So if you change medium, if you change radius of curvature, then that means it directly affects the refractive index, then the focal length will change. Otherwise, you're taking little piece of the lens or the whole lens does not affect the focal length. That is your first part of question. Now, second part of the question is, if I have just taken the same thing, I'm just taking half piece of the lens like this. Okay, only the top portion is available. Will it change the position of the image? Suppose I have a candle or a tree or something I'm using here as an object, and I have some situation that maybe I'm getting an enlarged image of it. Okay, so if that is the case when I have the whole lens, but if I'm just taking half part of a lens, will the position means this is the image is formed on the right side. No, not necessary. I'm just taking an example and asking, will the image position gets affected? And also, will the size of the image, because now only half part of the lens is used, do you think the image will also just be half? That is only the half part, the bottom part is not available. Do you think that will happen? Position and size of the image, will that get affected if I'm just using part of a lens? Yes, Anushka, what is your opinion?
No, it won't get affected.
Okay. Adit, what is your opinion? Any lens it can be, okay, for now. Yes. Is it that if I cover half part or some part of the lens, the position of it, like most of the lens will be on this side itself, or let's take only half of it, will it get affected? Let's say the image is formed behind in this case. Okay, I'm just using half of it. So will it affect that it will just come in front or maybe go behind the mirror? And will the size become half? Whatever is the size of the object, will it just show a little part of it, maybe only the frame part? Do you think that will get affected?
No.
Okay. Nidhi, what do you think?
No, ma'am. I don't think it'll be affected.
Correct. It's not going to affect. Okay, so if you have, you do, they do give you these kind of questions. It's not going to affect the position, the size, or the nature of the image. Okay, But yes, the intensity of light that can get affected. But apart from that, wherever the expected image is to be formed, or wherever, whatever size it should have, and whatever nature should it have, it will show that kind without any effect. It will not change if you're using part of the mirror or whole mirror. But yes, the amount that is entering into that, because only half part is utilized. So what is the thing that will get affected? You can mark that only the amount of light entering that will get affected. If amount of light entering is less, that means you're not going to get a bright image, you will get a very dim kind of image. So amount of light entering, that will get affected, and because of that, the intensity, okay, intensity of the image, that means how bright or how dim the image will be formed, that will get affected. So image of intensity of image will get affected. So if it is like half or some part of it, used amount of light, if that is less, the intensity will decrease. Only this thing will get affected. Rest, everything will be as it is. Focal length as it is, position, size, nature of the image, everything will be as it is. Yes. Once done writing this, then tell me. And also, I'm just marking, if you're referring Selena book, then ABCD sections you have. We have covered everything that's from fifth A. The A part, everything in detail has been covered up. So do not pile up your work. The PDFs have been sent to you. You will start with your work for this week. The work is you will do fifth A as the weekend work. Okay, fifth A, you will start with it. By weekend, you're supposed to submit it. Okay, fifth A, everything has been covered up. Now, next will be mostly based, the B part is all based on the diagrams. I'll just give you a little brief about how diagrams are going to be looking like. Okay, so everyone is able to see this. The screen is visible to everyone. Just check that. Are you all able to see this image?
Yes, ma'am.
Okay. Let me take a, let's take a penguin here, the photo of a penguin. Now we're just understanding two concepts. We're not doing the whole diagram that we will be doing tomorrow. So the thing that you see on the left side, okay, that is this one is the object. And after the rays are coming from that, these are all the incident ray coming from that object. It hits onto the convex lens, and then finally it comes out getting refracted. And these refracted rays, according to some rules, we need to know those rules, will all come and meet at this point. This point where it is meeting will be the start of the, or the top portion of the head. Okay, and you are always supposed to draw a line wherever, if it's coming and meeting at the bottom, always draw a line towards your, that is vertical line towards the principal axis. And the image, if any time this is the principal axis, image is formed at the bottom portion, image will be inverted. How is the image inverted? Inverted images means upside down images. Suppose if this is the tree, inverted image means this will look like this. Upside down images are called as inverted images. And do this combination thoroughly. Inverted images are always real images. Real images means the rays are actually going to meet in reality. We are not supposed to do that back tracing. There is no need of such things to do. So inverted images will be formed when the rays are actually meeting. So this combination is a fixed combination. You will always remember real images are inverted, or sometimes when you do the diagram, you get some information, you get the idea, okay, the image you got is inverted. By default, you will say That means it is a real image. This combination you will remember fixedly. And let's say I will just try to shift the image of the penguin. So every time you're able to see the image is formed on the right side. Now, only under this condition, you are able to see, we'll see all that condition, just getting the idea. This is your object, O, and this bigger screen of it is the image. Now you can see, is it inverted or is it erect? How is the image compared to the object? Yes, Michelle. How is the image? Is it inverted or erect?
Is it erect?
Yes, this is erect image. It's not upside down. So erect image, you can also use another word for it. You can use this as upright. Use any one keyword, whichever you remember. So upright image or erect image, they are always virtual. Virtual means they're actually not meeting. You are trying to, your brain tries to trick in such a way that it's trying to focus it back. Now, if you clearly notice, there are dotted lines used here. Whenever you have images with dotted line, that means they were actually not meeting. After, see, two rays came out, they were going away from each other. Can you see they are getting diverted? They're not going to meet anywhere on the right side. But you are trying to make it meet backward with dotted line where they're meeting on the left side. So these are called as back tracing. Back tracing happens when the images or the rays are not actually meeting after refraction. And you are trying to make it meet by using dotted lines. So these cases are considered as the case where you're getting erect image, and erect image is virtual image. Virtual means it is going to be, it's going to be not meeting in reality and you are trying to make it meet. So this combination you will just remember, ray diagram we will be doing tomorrow. So erect image will be virtual and inverted image will be real. Real means really meeting. Virtual, you are the one who's going to make it meet by using back tracing concept. Okay, revise up everything that we have covered. Tomorrow we'll see the rules and we'll start with some diagrams as well. So we'll meet up tomorrow at the same time.